Hi, welcome back to the OWASP Appsec tutorial series. My name is Jerry Hoff, and this is episode number 4, HTTP Strict Transport Security. This series is for anyone who wants to learn more about building secure web applications. And in this episode, we will be covering HTTP Strict Transport Security, also known as HSTS. Transferring data in a non-secure way is a major issue that affects the security of many websites. You've definitely seen examples of this. It's very common for websites to use HTTPS only on the login page. And then after the user has logged in, the connection is then downgraded to HTTP. Although the application did send the username and password over a secure channel, the user's data is put at risk. To illustrate this point, let's look at example number 1. A website that uses HTTPS only during login. Imagine someone is using a shared internet connection, for example, at a coffee shop where free Wi-Fi is offered. The user wants to access their work email account, so they navigate to the page and enter their username and password. Since the credentials are passed over a secure HTTPS connection, they will not be visible to attackers who are monitoring the network traffic. However, after login, the site downgrades to an HTTP connection. Data transferred over HTTP is visible to anyone on the network. In this case, the data includes a list of emails, which can contain very sensitive information. And on top of that, the session cookie is also transferred in the clear. If an attacker can copy the session cookie, they can hijack the authenticated session and do anything the user can do. So using an HTTPS connection on the login page does protect the password, but by then downgrading the connection, attackers can see sensitive information, including the session cookie. Organizations should protect all data in transport by running their entire website over HTTPS. HTTPS ensures the data is authentic and it has not been read by anyone else. Moving an entire website to HTTPS goes a long way in securing data. However, in certain situations, attackers can undermine the security of HTTPS. To illustrate this, take a look at example number 2, man in the middle. Imagine the same user checks their email again on a site that fully supports HTTPS. However, as many users do, they type in the HTTP address. Their web browser will fire out the request, and the web server will respond with a 302 redirect pointing the web browser to the HTTPS enabled page. The user then sends the request again to the secure page. Although this is much safer than before, there is still risk because the non-secure HTTP request is still vulnerable. So to see how this can be exploited, imagine the attacker has set up their own access point in a cafe, airport, hotel, business, anywhere. By offering a free internet access point, it won't be long before users come and try to connect. Once a victim is connected directly to an attacker's access point, the attacker can easily read all the HTTP requests. The attacker can then easily generate fake responses or modify a legitimate response to contain malicious code. This exploit is common and is known as a man-in-the-middle attack. Recently, a solution has been adopted to minimize as much as possible the chance of a man-in-the-middle attack happening. The solution is the Strict Transport Security HTTP header. The header is sent over a secure connection and causes a change in the web browser. The header instructs the browser to change any HTTP links to HTTPS automatically in the browser. This header also offers one more major protection against man-in-the-middle attacks. In the past, HTTPS error messages informed the user there was a problem, but allowed users to still continue through anyway. Users who were not familiar with the risks involved in insecure HTTP connections would click through the error messages anyway, often putting their data at risk. Strict Transport Security removes that option. Users cannot proceed if a secure connection cannot be made. Implementing Strict Transport Security is language independent and only requires adding a simple header to any response. The Strict Transport Security header, however, is only honored if the browser receives it over an HTTPS connection. Here's a response that contains the strict transport security header, along with a time limit in seconds. During this time limit, the browser will convert all HTTP requests to HTTPS and will deny any non-secure connections to that site. The strict transport security flag is not supported by all browsers yet, but it is supported by Mozilla Firefox and Google Chrome. Hopefully, other browser vendors will be adding support for this flag in the future. For more information regarding HTTPS, let's turn to the OWASP website. Search for the Transportation Layer Protection cheat sheet, which will provide more information on securing web applications using HTTPS. So to wrap up, websites sending or receiving sensitive data should protect all data using HTTPS. The strict transport security header will ensure the browser automatically converts HTTP links and bookmarks to HTTPS, which does not eliminate but greatly reduces the risk of a man-in-the-middle attack. That's it for this episode of the OWASP Appsec tutorial series. If you have any questions, comments, or want to contribute to future episodes, please contact me through Twitter or email. Be sure to subscribe to the Appsec tutorial series YouTube channel to find out about new shows. Special thanks to Michael Coates, who greatly assisted in this episode. Also, special thanks to Simon Bennett, Eric Sheridan, and Jim Manico. This is Jerry Hall signing out, and I'll see you next time.